Thank you, and thank you for the Belgium Drone Federation to invite us to have a quick chat here this afternoon. I would like to address the topic of enabling BVLOS operations through mobile private networks because that is exactly what we at Citymesh are doing already for some years. Maybe for the people who are watching that do not know Citymesh, which might as well be the case, we're a Belgian operator, of course, a rather small one if you compare us to Proximus or Telenet or Orange. But nevertheless, we are one of the owners of a nationwide 5G license in Belgium, besides also owning a 4G license. But as opposed to the what we call regular operators who mainly focus on B2C, business to consumer, we do not. We only build private mobile networks specifically for the needs of the enterprise and businesses. We address there in those markets mainly business critical communications and mission critical communications. Being business critical, well, you need communications to be able to run your business. And mission critical, well, if you look at emergency services, if you are in the need or in despair and you want to push a button and you want to make sure that somebody at the other side hears you, that's what we call mission critical. Or for example, if you are running autonomous vehicles at a big steel plant, for example, and you press the emergency stop button, you really want that machine of maybe a couple of 100 tons to stop in a split millisecond. So that's why we need mission critical wireless communications. And that's exactly the types of networks that we build as Citymesh. We're based in Bruges. We're about, today the slide is a little bit out of date. We're about 100 people already. And our mother company is the company Cehica, which is a large IT integrator here in Belgium. Now, maybe a little bit on those mobile private networks. Like I said, we are building those based on the 4G and 5G technology to make sure that wireless communications for the first time is really comes first. Up till today, it was mainly fiber, copper, or maybe even coax if you wanted to make sure that your factory assembly line or whatever that you wanted to have connected was reliable. But with the introduction of private LTE networks and even more with 5G, we can for the first time rely on wireless communications to get that same level of SLA or that same level of resilience in those networks. Now, of course, to make that a little bit more tangible, we at Citymesh were looking at a showcase offer, something that really enabled our customers to see what we mean by this mission critical communications. And maybe one little step back, as you all know, if you want to control a drone beyond visual line of sight, one of the most important components of that control is connectivity. If you are a pilot with visual line of sight of your drone, you're probably using some kind of Wi-Fi protocol by DJI or something other proprietary protocol, and then you have a range between maybe 1 to 5 kilometers in optimal conditions. But if you want to steer your drone over larger ranges, maybe 10, 20, 100 kilometers, you need to make sure that every command that you send to your drone, be it go up, down, left, right, or stop or land, really gets to your drone. Even more, if you want to have some real feedback from the drone, for example, video images, LiDAR images, whatever, you want to make sure that you also have the tools to get that back in your remote operating center. Now, of course, the public 4G and 5G networks that already exist today, definitely here in Belgium, are of a good quality, but they are built top down. What do I mean by that? We as people and our smartphone devices, we all walk around at street level or are in some kind of building, but we are rarely in the need of connectivity at the height of 90, 100, or even 120 meters. So all the antennas that are built for these nationwide B2C networks are, as you're flying your drone at let's say a height of 90 or 100 meters, you have two problems. One is that, of course, by the down tilt of those antennas, the signal quality is probably less than you have at street level. But that's not the biggest issue. One of the biggest issues, and that is what is visualized here in this drawing, if we take the top drone, then you can see that that drone can see multiple cells, multiple masts by multiple operators, all operating at probably the same frequency. And this creates what we call interference. And there was a study done by the KU Leuven, I think a year or two ago, that actually showed that when you go even higher than 75 meters, that the reliability of having a good signal drops by not less than 15%. Okay, 15%, that could sound not very much, but if you take that 15% of the time that you are flying, you could do without any communications, well, then you see that you might have a problem, especially, like I said, in BVLOS operations. Now, what we are doing even today and have been doing over the last 2 years is building the same networks, 4G, 5G, LTE networks, but we are tilting those antennas upwards and we're building them solely for business applications, of which the drone BVLOS operations are one of them. So we build these bespoke networks and we design them in such a way that we have optimal connectivity for the drones, but with minimal interference. We've dubbed this little project of ours Safety Drone. And why Safety Drone? Because one of our first clients was actually the fire department in Kortrijk and some police departments as well, who were really interested to see how a remotely operated drone could aid them in helping them put out fires and react to traffic incidents and stuff like that. So what we did, we called our primary vendor, which is Nokia, based out of Finland, and they actually had a drone that they built themselves. Obviously, they also provide the network, so we had like a box solution together with the remote control software. We installed the drone on the top of the firehouse or the fire station in Kortrijk. We also deployed a mobile private 4G network at the tower of that fire department there. And we actually built the remote control office in our HQ in Bruges. So you must visualize that we have a drone sitting in Kortrijk on one hand, and then we have our licensed pilots, of course, licensed BVLOS pilots, sitting in Bruges and waiting for an emergency call to come in. We are fully integrated with 112 dispatch, and so we are actually pinged automatically once there is a fire or a situation where the drone could be useful to send pictures towards those firemen before they even leave the fire station. Now, today, we've expanded our portfolio of solutions with another drone. Like I said, we used to have only the Nokia solution, which had some advantages, but we also are doing some projects with the box solution of DJI. Now, back to the concept, which is actually today even more than a concept, but here is visualized how this all integrates to one another. I'm going to start from the left to the right. On the left, you see, well, actually in the middle, you see the fire station where there's a drone on the top of the roof, obviously in the docking station, so it's not exposed to the environmental like rain and extreme weather conditions, and it's always being charged. At that site or at the city center, we also deploy these private 5G networks that can be used for the drone, but obviously also for other applications of the fire department. The drone is connected to that private mobile network, so we are always sure that that drone, wherever it will be, has a reliable and steady connection for both the telemetry, but also for sending back HD video, thermal images that we, at the other side, transmit back to the firefighters. So like I mentioned, once there is an emergency call coming in, the drone takes off automatically. Of course, being overviewed by one of our pilots, we get the coordinates of the incident. The drone takes off and flies towards the state of the place of emergency, and meanwhile relaying back its coordinates, its telemetry, its vital functions, and like I said, the video feeds back to our HQ. In our HQ, and that's what you see on the right-hand side, we feed all that video streams and data streams into our data center and expose them to whoever is allowed to see them. And of course, fire and police, it's rather critical imagery, so we make really sure that we do not transmit any of those data to any parties who are not allowed to see it. I'm going to skip this one in sense of time. So we have actually built this what we call remote operating center in Bruges in our HQ, and we are actually in the phase of deploying 2 more, probably in Antwerp. There will be one and with our mother company Sehica in Limburg. And we will offer this to our clients. We will offer end-to-end solutions based on connectivity. Of course, that's our what we call métier. That's our bread and butter. We will provide connectivity to whatever BVLOS operation you might have. Today, it's all about flying drones, but we also have customers that are in the business of sailing autonomous vessels, near shore, offshore, and anything in between. And these remote operating centers will enable them to start easily with pilots. They do not need to worry about getting that drone, whatever it may be, connected to a data center or their HQ. They do not need to worry about any infrastructure. That's all being taken care of by us, by Citymesh. Now I'll show you a little bit more on how these mobile private networks are enabling these BVLOS operations. One of the most, what I personally think that is a really nice project is what we did at Brussels Airport Company at the beginning of this year. Brussels Airport Company is one of our enterprise clients who asked for a mobile private network based on 4G and 5G. They have both technologies there. And their incentive to do that unfortunately came after the incidents, the terrorist attacks of, I believe, 2016, where they saw that once that incident happened, actually all communications just stopped working. And they really needed this, what I talked about in the beginning of this presentation, that mission and business critical communication layer. So they asked Citymesh to build their own 4G and 5G network based on our spectrum, of course, but all the network is owned by Brussels Airport. Now that network was installed by the end of last year, and then they started thinking, okay, what is one of the most visible things that we can do with this mobile private network? Of course, besides connecting user equipment and tablets and so on. And they saw what we did with the fire station in Kortrijk, and they asked, can we think about enabling some of our operations by issuing a drone? Of course, we all know the incident that happened at Heathrow a couple of years ago. It's never a good idea to start flying drones at a live airport. So we sat around the table with all the parties involved, BCAA, Skies, Brussels Airport Company, of course, fire police, and all other stakeholders that are running an active airport. And we decided to just do it. Of course, with all safety measures in place. We had, of course, a SORA, we had the TSA, we had everything we needed. And we actually tried out 3 cases, and I will showcase one of them in a short movie. So it's exciting to see if these things will start playing. No, doesn't look like it. No worries, I'll just orally say what we did. So we deployed a safety drone on top of one of the fire stations at besides the runway. And we actually trialed 3 use cases. One of them was seeing how a drone could aid in search and rescue when there was, for example, a crash incident. That was pretty obvious, even at an active or even at an airport, the fire brigade needs to get clearance to cross any runway. Even if there's a crash of a plane, so there's a high emergency, fire department needs to be all aligned, and then they get clearance from the tower to cross the runway. Now that takes some time, of course, and that time is critical to see what's going on. And at the airport operations center, it's not always clear to see what is going on when there is an incident. Now, deploying this drone on top of a fire station really enabled us to fly around the runways. So we did not cross any live runways, but we were much faster than the fire brigade that rushed to an incident. I think we were about 5 times as fast. Another one was gate inspection. And the last one was wildlife inspection, which we actually repeated last month. So this was all possible because they had this private mobile network. We operated these drones, and that's really important to state. These drones, based in Brussels at the live airport, were piloted by our pilots in Bruges, like 110 kilometers away, of course, in close collaboration with the tower and with the airport operating center. Besides that, besides having control, having these really critical communications, enabling all these use cases, the costs of doing this was actually really low for the airport. We streamed 4K video, we streamed thermal, we streamed, of course, telemetry, which is not that big of a payload, but nonetheless, there was really no additional cost for streaming all that data hours in a row, days after one another. Unlike if you do that over a public network, then you pay for every bit that you transmit over a public network. Not so if it's, of course, your own network. And I think I'm running out of time. So Elwin, back to you.